The following is the video solution from JSDT Solutions. Question 8.1 says, a Google Chromebook costs 14,500 Rand and depreciates, by 13% per annum compounded annually, calculated on the reducing balance method. Okay, so this is compound depreciation or compound decay. Okay, so we know that it is compound. We're just going to keep that in mind. Calculate what a Google Chromebook will be worth after exactly 5 years. So we're just watching this depreciate. Okay, so we know that we're using the compound decay formula, which looks like this. A equals P times 1 minus I raised to the power of N. And so the amount that we're starting off with, this Chromebook initially costs 14,500. So that is our principal amount. That is 14,500. And then 1 minus our interest is 13% per annum compounded annually. So that is 0.13. And then we know that it depreciates for 5 years. So raised to the power of 5. And we can clearly see we're trying to find the value of A. So let's find our answer and round off to 2 decimal places. So the Chromebook would cost exactly 7,227 Rand and 10 cents. So that is our answer. Moving on to the next question. Question 8.2 says, Khoza deposits 15,000 Rand into a bank account for a period of 10 years. The interest rate for the first 4 years is 6% per annum compounded monthly. For the next 6 years, the interest rate changes to 10% per annum compounded semi-annually. And then they say 8.2.1, convert the nominal interest rates to annual effective interest rates. Answer is correct to 4 decimal places. Okay, so you see in this question, it's funny how they started off telling us all this information about this and then they jumped to nominal and effective interest rate, but that's fine. You see, with nominal and effective interest rates, this is how it works. So the bank quotes a specific amount and says it's compounded monthly, right? So for example, 6%. Just because 6% is compounded monthly and this is the interest rate they have quoted you, it doesn't mean this is the amount that you end up getting if you look at it within a full year, Because interest gains interest on interest. What happens is at the end of the year, that interest rate is much higher. So you will notice that the effective interest rate, the annual effective one, is always going to be higher than the nominal, the one that the bank quoted. So that's just a bit of a backstory. And the formula to calculate the nominal or effective interest rate looks like this. It's 1 plus I effective is equal to 1 plus I nominal over N raised to the power of N. So this is the nominal, that's the effective. This is usually to the power of 1, but it's not necessary, It's just because it is compounded annually. So for both interests quoted, that different compoundings, we're going to use this formula. But from this formula, you can already see to find the effective interest rate, and they specifically said they wanted it as a rate. So we're going to simply take 1 over, and so this is going to be 1 plus I nominal over N to the power of N minus 1. And so this is what we're going to use. So the first info that we had that the interest rate for the first 4 years was 6%. So the interest was 6%, but it was compounded monthly. So this first interest was compounded monthly, and let's just deal with the 6%. So we will say to get the effective interest rate here, we'll say 1 plus, and this is what we were quoted, 6% per annum compounded monthly. So 6% as a decimal is 0.06. And then it's compounded monthly, so we divide it by 12 so that it gains interest every month. And then raised to the power of 12, minus 1. And we can get that interest. So this is what we have. And they said round off, but they did say find the rate and then round off to 4 decimal places. So I'm just going to rewrite this as it is first, and then we're going to multiply. So don't write the full thing, just enough. And then we will multiply by 100 so that it is expressed as a rate. So multiply by 100. And so our answer, okay, rounded off to 4 decimal places, would be 6.167. And then this 8 after that fourth decimal point of 7, that's going to help that round up to an 8. So that rounds up to an 8 and we'll say percent, and that is our answer there. And then the next one will be the 10% per annum compounded semi-annually. So let's just put that down. That's the 10%. Okay, so we're going to use the same formula again. I effective equals 1 plus, but in place of our interest, it is 10%. So that's 0.1, or you can say 0.10, it's fine. Okay, now it's compounded semi-annually. So that will be divided by, if you're looking at semi-annually, that's half a year. So half a year, meaning the year is divided into 2 parts. It's going to earn interest twice in a year. So divided by 2 raised to the power of 2 minus 1. And then that's all we're going to just go ahead and change over here. We're going to change that. Okay, and that gives us 0.1025. And if you convert it to a rate, it's just going to move up by 2 decimal points. So if you just multiply that by 100, you can do that, but it's not really necessary. All you're going to get is 10.25, and that is it. Okay, so no other points come after that. So those would be our answers. That's our first answer, and that is our second answer. We'll see why they wanted us to convert it. Okay, moving on to the next question. Question 8.2.2 says, hence use the effective interest rates, or otherwise calculate the future value of the savings at the end of the 10-year period. Okay, that was really nice of them. So now you don't have to consider the compoundings and stuff. They're all just going to be compounded annually, okay? So let's look at our timeline, because this is clearly a timeline question. So 15,000 is deposited first, and then it's deposited for a full 10 years. We'll keep it like this. Our timeline, we can start at T0, okay? And then what happens here is 15,000 Rand is invested. Then remember how first we had the interest rate for the first 4 years was 6% compounded, monthly, per annum compounded monthly. But we don't have to consider that anymore. Now what we have to take is this, okay? And we're going to use it like that, clearly. So just use it as a decimal. Okay, so we need to take it like that. So for the first 4 years, from T0 to T4, and the reason we look at it like that is because, so this is where the money comes in, and then after a year, this money will gain 1 year's worth of interest, okay? And that's why we start at T0. So from term 0 to term 1, the interest rate was, and we're just going to use this interest that we have here. So that is that 6.1678, okay? 6.1678, we're going to use that. And then for the next 6 years, so till T10, that is, we're going to use this 10.25. 10.25. Okay, so let's go ahead and invest this money. This is going to be compound interest growth, because money is going in. It gains interest because of the interest attached to the account at these different time periods. So we're going to use this formula, A equals P times 1 plus I raised to the power of N. Okay, so this is trying to see what the future value will be. It's going to be, we start at 15,000, and then let's look at the first thing that happens. This money gains interest at this rate. So as a decimal, this is now going to be 0.061678. Okay, now it's not going to be, I don't know why I put it up. It's not going to be compounded monthly anymore. It's just going to be like that. So raised to the power of, now for how long did it have this interest rate? It had it for 4 years. So we're going to raise it to the power of 4. Not 4 times 12 anymore, because it's not even compounded monthly anymore. Okay, we're just looking at that interest per year. It's the effective interest rate. Okay, so it's an annual interest. So now the next interest we had was 10.25, right? You're not saying plus, because no money is going in again. It's just one deposit of 15,000 and that's it. So you're multiplying, okay, so that it has both interest attached to 15,000. Okay, So 1 plus, and we have 0.1025 raised to the power of, that stayed for the remaining 6 years. So raised to the power of 6. And that is what we have. And let's finally just get our answer. And our final answer is going to have 34,224.26 cents. And that is our answer. And that is it for question 8.2.2. Question 8.2.3, the last question for question 8, we have the interest rate for the first 4 years remains 6% per annum compounded monthly. And then for the next 2 years, okay, we're just going to have to put down our timeline again. Okay, so it's still for, I think, 10 years. Yes, it's still 10 years, but let's see. They say the interest rate for the first 4 years, right? It remains 6% per annum compounded monthly. Okay, so till T4, it's still 0.06, but it seems like they're using this now, okay, over compounded monthly, so divided by 12. And then they tell us that for the next 2 years, the interest rate is now X% per annum compounded quarterly. So for the next 2 years, from T4 to T6. So the interest is X% per annum compounded quarterly, so divided by 4. And then they say for the last 4 years, the interest rate is X% per annum compounded semi-annually. So also the same rate, okay, but just compounded semi-annually. Okay, so from T6 to T10, it is X% as well, but compounded semi-annually, so divided by 2. Okay, so we just know these are the interest rates attached to all of these. And what they tell us is if Koza receives 48,897 Rand, okay, and 3 cents at the end of the 10-year period. So this is what he gets at the end. It's 48,897.03. At the end of this period, the 10-year period, determine the interest rate for the last 6 years, i.e. the value of X. Okay, so just find the value of X. So it's still the same amount going in. It's still 15,000 Rand. And we're just going to have to substitute this and then find the value of X. Okay, so again, using the compound interest growth formula, we would say A is equal to P times 1 plus I raised to the power of N. So the final amount, which we have, okay, as 48,897.03 is equal to the investment, which is 15,000 multiplied by, and now we just need to be careful. Notice that there are 2 different interest rates, but remember there are 3 different compoundings. These ones are exactly the same, but the compounding is different. So you need to have 3 brackets. Just remember that. So it's going to be 1 plus, and the first interest rate is 0.06 over 12. And this lasts for how long? From T0 to T4, which is 4 years. Okay, but remember that this is 4, but you need to multiply it still by 12. The reason is it's compounded monthly now. So you need to ensure that this is in terms of months, okay? And it earns interest every month. And then we'll say multiplied by, and what do we have? We have 1 plus X over 4 raised to the power of, and this was for 2 years, but it was compounded quarterly, so you'll say 2 times 4. So it is 8 quarters in total. And then multiplied by 1 plus, and our interest there is X over 2. And that lasts for 4 years. So that's 4 multiplied by 2. Okay, so semi-annually. And that is what we're solving for. Okay, so let's go ahead and solve for X. We'll find the value of X in all of this. Let's look for a quick way to find X. So since X is here, and these 2 are also still being multiplied, we can simply get rid of everything here. So we're dividing both hand sides of this equation by all of this. Okay, that will all be numbers, not including X. So divide both hand sides of the equation by, and that is going to be 15,000. I'm just going to put that in decimal form or as a fraction. 1.0.06 over 12. Okay, yeah, that's fine. 1.005, and then 4 times 12 is 48, so we're going to say raised to the power of 48, and we're just dividing both hand sides by this number. Okay, so we know that these would cancel, right? They'll be gone. But this, let's just simplify that as well. That is, well, they have the same exponent because 2 times 4 is 8. 4 times 2 is also 8. But their base is not the same though. So this is a situation where you have, like, for example, x times y, right? But they're both raised to the power of 2. You could have just written them as xy all squared. Okay, so we can't just do that. So this is 1 plus x over 4 multiplied by 1 plus x over 2, and then they're all just raised to the power of 8 is equal to, and let's finally find this answer. Okay, and as a decimal, I actually don't like to leave it as a decimal. I would rather just solve first because I just don't want to keep decimals. So if it's still equal to all of this, we're going to have to now, to get to the x, you see that the next challenge would be this 8. So you need to find the 8th root of both hand sides of the equation. Okay, so if you find the 8th root and the 8th root, I'm only doing this just so that if we make a mistake, we can always just backtrack. So this is now going to be, let's just multiply them. They would give us, it's going to be, yeah, I can see how it's going to be a quadratic equation. So this is going to be 1 times 1 is 1, and then that's going to be an x over 2, and then an x over 4, and then they will give us x squared over 8 is equal to, and then all of that. Okay, at this point, it's safe to just find this answer because we're going to have a quadratic equation here. Okay, so this is 1.125, and then 0, 0, 0, so it really just rounds off to this. Okay, so let's just get this as a fraction. 1.125 as a fraction is 9 over 8. Okay, so let's rewrite. I'll just write this with the x squared first. So we have x squared over 8, and then plus x over 4, plus x over 2. We'll add them using LCD. And so this is 9 over 8 that we have. Okay, so this denominator is 8, and we can make this 8 by simply looking at all their denominators and asking how did we get to 8. So here, this is already 8, so that will stay x squared. Now with the second term, we have x over 4. So how do you get this 4 to become 8? You multiply by 2 in the numerator and the denominator. So that becomes positive 2x in the numerator. And then this, you multiply that numerator and denominator by 4 to get that denominator to be 8. So that's going to be positive 4x. And then for the 1, you just multiply that by 8 is equal to 9 over 8. And here we have equivalent fractions, so we can just get rid of the denominator. You can just decide to multiply both hand sides of this equation by 8, and then it's gone. So therefore, x squared, and we have positive 6x plus 8 is equal to 9. And if you transpose the 9, we have x squared plus 6x, and 9 minus 8 is negative 1. We know this can't factorize, so we're going to have to use the quadratic formula. Okay, so this is equal to, and we'll say x is equal to, and we have negative b, so negative, and then b is 6 plus minus the square root of 6 all squared minus 4 times 1 times negative 1 all over 2a, which is 2 times 1. And let's get our solutions for x. Okay, so 2, 7, or x is equal to, and if you change that to a minus, okay, it's already negative, so you know that the interest can't be negative. So just keep that in mind. So we're not going to accept this answer. We'll accept this one. And the question specifically was, what is the value of x? But we know that this is a rate. So we're going to put it as a rate by multiplying it by 100. And so therefore, x is equal to, that's going to be 16.23%. Okay, so that is our answer. That rate is 16.23%. And that is it for question 8.